Hello, Vedantu Karnataka students. ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? ನಮ್ಮ ಹೆಸರು Shreyas, Captain Shreyas. I hope you guys are doing great. And quickly mark your attendance in the chat box. And today is the first lecture of your Diwali lighters. Like I had told you, I'm going to start off with the KCET basics ga start ಮಾಡ್ತೀನಿ ನಾವು. Okay, so right from the fundamentals, right from the scratch, so that every student becomes a hero. Every student from zero becomes a hero. We will see how much ever we can do. If we feel that, okay, sir, too much head, pain aagta ide, don't worry, you tell me, we will stop the class there, we'll take the second part later on, and we will make sure everybody understands every single thing out here, and the entire PDF of the session will be available to you in the yes, where is it going to be available? In the Telegram. Where is the Telegram group? Yes, Telegram group link illi nodi. Join the Telegram channel. Yes, join it, you will get the PDF ಬೇಕಂದ್ರೆ join ಮಾಡಿ ಇದು Telegram channel. All right, so let's begin with the class. And hello Krishna, hello Anand, nice to see. Hello Abhishek, get all your friends. Hi Kushmalt, hi Sagar, Sudarshan, welcome. And all the warrior Pandus, all my Namma Karnataka students, welcome aboard. My name is Captain Shreyas. I've been teaching for more than 13 years now. And over this last 13 years, I have sent many students into top-notch colleges. And more importantly, these students were not toppers, they were average students. That's why I always tell this to my students, because to make a topper into a better topper is easy, but to make an average student into a topper is where you need a lot of patience and lot of skills. And with your hard work and my mentorship, I'm pretty sure that will happen. So make sure you're subscribed onto the channel and make sure you're liking the video. Thank you so much for doing it and putting up all the hearts and all the love in the chat box with all those fires. Thank you Indrani. Hi Uday. Hi Kannadiga 1801. Okay, welcome. So let's begin. Now we'll start off with scalars and vectors. All right, get ready now. Yes, and you will see that in this particular chapter we are going to see some basics of vectors as well as kinematics, and kinematics is a lot of fun. And you will see that kinematics is basically the study of how things are moving. Like for example, I will show you, look at these beautiful red and blue color cars. You can choose the velocity, the location of each of these cars, you can choose how fast they are moving, everything, and you can just press run and you can see how these cars start moving, and you can also see their graphs. I can also choose some what do you say, I can also choose some different values maybe, and you will see that they move very differently. So kinematics is the study of how, where things move, how fast they move, when will they reach, where will they be, and all of that. And to know all this, you need this term called as vectors. You might have heard about vectors, but we will be doing a lot about vectors and what it is, etc. Like this is, for example, called as a vector quantity, which has a arrow, which has a direction in it. So let's start with it. It's going to be a beautiful session. Yes, this is the this is the YouTube series for KCET, correct? Yes, Mandar, I did it initially. The signature step, it was done. All right, see, what is a scalar, what is a vector? Yenidu, let's understand. See, if you take any physical quantity, what is a physical quantity? You will be like, sir, what the hell is this term physical quantity? What is the meaning of the word physical quantity? any quantity which can be measured, which can be measured. Anything that you can measure is called as a physical quantity. Example, can I measure the temperature of a person? Temperature of a person? Definitely. Can I measure the height of a person? Yes. Can I measure the mass of, the object? Yes. Can I measure the volume of some object? Yes. Can I measure, the force a person applies on somebody? Yes. Can I measure the work done by some motor? Can I measure the power of my car? Yes. All these are measurable quantities. Hence, they are basically physical quantities. Things like how happy am I? How sad are you? How excited are you? All these things, they are not physical quantities. So I am putting it in a cross in this red. Sir, I'm very excited. And how do you show your excitedness in the chat box? You put up a lot of fire emojis. You put up a lot of hearts. You show your likes. So that is a vague way of measuring, how you love the session, how you enjoy the session. But it's not exactly a physical quantity. I am 5 happy. I am 7.5 happy. Doesn't make any sense. So physical quantities are the ones which can be measured. Temperature is 37. I know what 37 is precisely, no matter where you go in the world or the universe. If I tell you I have applied 10 Newton of force, you know what 10 Newton exactly is. It's not a vague idea for everyone. This session 1 to 1.5 hours, not more than that. So now, based on this, you classify it into 2 categories, scalars and vectors. So let's understand this, guys. Very, very crucial. Scalars and vectors. Let's understand scalars and vectors. Scalars, basically, you will see only magnitude of it is enough. Magnitude is enough to describe it. Only magnitude is enough to describe it. Whenever you have to describe somebody, yen martiva ನೀವು? Sir, tell me more about, say for example, Rajkumar sir. Will be like, Rajkumar was like this, he was like that, his appearance was like this, he was captured by Veerappan. So we'll describe him, right? Same way, when you have to describe a scalar quantity, only tell me the value of it, it is more than enough. For example, let me tell you, I ask you, what is the top speed of your car? What is the top speed of your car? Yen ನೀವು top speed bike ಗೆ? You'll be like, sir, ನಂದು bike ಗೆ top speed ಗೊತ್ತು ನಿಮಗೆ, it is 200 kilometers per hour, sir. Wow. ಏನ್ ಡೈರೆಕ್ಷನ್? ಯಾವುದು ಡೈರೆಕ್ಷನ್? 200 kilometers per hour, north ಗೆ, south ಗೆ? You'll be like, hey bro, what are you asking, bro? 200 kilometers top speed, north or south, huh? What is this? North or south? It is 200, whether you go north, whether you go south, it is same thing. East, west, up, down, it is same thing. So what is this direction you are asking, bro? Only magnitude is enough, bro. So that's why speed, top speed, all this, only value, magnitude, enough. That's why it is scalar. Or mass, for example. Mass is a physical quantity. Yes, mass is a physical quantity. I just told you it can be measured. So, sir, what is your mass, sir? I'll be like 60 kg. 60 kg, yeah, what direction, sir? West gear or east gear? You'll be like, hey, what is this asking you, bro? West, east, 60 kilos, 60 kilos. That's it, no direction. So, scalar, only magnitude. Yeah. Same way, distance. The distance between 2 cities, distance between 2 places, scalar. All these are scalar. There are many more scalar quantities like volume, no direction. Even current is a, scalar quantity. Even density is a scalar quantity. All these things, time, area, for most of the places, they are basically, all these are physical quantities which are scalars. They are basically physical quantities which are scalars. They have only magnitude. Many people get confused with the current. Sir, current Has the direction? No, sir. Current is flowing in the wire like this, from positive to negative, sir. So current ke direction is there, sir. What are you saying? Current has no direction. See, even if it has direction, I don't care. See, this car was moving in north direction, example. I don't care about the direction. No, I don't care. Not interested. Even if it is there. So when I'm not interested, I'm only happy with magnitude. I don't. Nange adu additional information beda. Okay, then I will be like, okay, that is scalar quantity. It only follows, it also follows simple algebra for addition and subtraction. Meaning 2 plus 2 is 4, 5 plus 1 is 6, 7 minus 2 is 5. Simple algebra, it will follow. 5 kg plus 2 kg, how many kg? Tell me the answer in the chat box. 5 kg plus 2 kg, how many kg? 7 kg. Everyone agree, disagree? Yes. So, scalars follow simple algebra. Now we will talk about vectors. You will see they are slightly different. Both magnitude and direction are needed to describe it. Both are needed, magnitude, direction. Just like you are going out, parents ask, where are you going? If you tell, I am going 10 kilometers away. Parents are like, okay, go 10 kilometers. Did they ask you where you are going? No, right? They just asked, okay, you are going somewhere, what are you doing? You're like, yeah, I am going 10 kilometers. Fine, only magnitude, value you told. That is scalar. Parents ask you, what are you doing? You say, I am going 10 kilometers. They're like, what 10 kilometers? Where 10 kilometers? To my friend's place. You told direction. You need both to tell your parents, sir, dad, mom, listen, I am going 10 kilometers to my friend's place. That is magnitude and direction both. That is vector. That is vector quantity. Understood? If you just said, I am going to my friend's place, you don't tell the value. Your friend, how far he stays? 10 kilometers. Okay. Hogi. No problem. You need both. That is why it is vector. Understood, guys? So both magnitude and direction needed. So quantities like displacement. We'll be learning more about all these things in a bit. Displacement, velocity, acceleration, force, momentum, all these things, momentum, electric field, magnetic field, all these things, etc. They are vector quantities and they follow vector algebra rules for addition and subtraction. We'll see that later on. But they follow different set of rules. 2 plus 2 may not be 4. Well, like, what, sir? 2 plus 2 is not 4, sir. How? I'll tell you. Example for this. 2 kg plus 3 kg, everybody agrees, is 5 kg. Scalar. 2 plus 3, 5. But look over here. 2 Newton towards east plus 3 Newton towards west. You will be like, sir, 2 plus 3 is 5. That is wrong. 2 is this side, 3 is this side, 2 is this side, 3 is this side. If you push like this 2 and 3 like this west, it won't be 5, no? They are opposite, they will cancel. So you will see it will be 1 Newton west. 1 Newton west, because west direction you have applied more force, east direction ge ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಆಗಿತ್ತು. So 2 Newton towards east, 3 Newton towards west. So 1 Newton is remaining towards the west. So you can see 2 plus 3 is not 5. That is why different rules. Here different rules. Artha aita? Everyone tell me quickly in the chat box. If you have understood this, the difference between a scalar and a vector, everybody with me? Give me a thumbs up, then we'll go ahead. Okay, great. Sir, so if that is the difference between scalar and vectors, so can you do some questions? Yes, let's do some questions, guys. Here is the first question on your screen. Identify the following quantity as scalar or vector: the mass of the object, number of leaves on a tree, and the wind velocity. Come on. Let's see if you can answer the questions. Vector, scalar, scalar, vector, scalar, vector, scalar, scalar, vector, scalar, scalar, vector. Identify the following quantities are scalar or vector. Mass of an object. Mass. Think what it is. Number of leaves, what it is, and the wind velocity. Very simple. Tell me the answer in the chat box: A, B, C, or D. Come on, my dear students. A, B, C, or D. Yeah. Yeah, Pradeep. We are starting off with the basics and we'll complete the entire syllabus, right? Part by part, part by part. Don't ask me when. Just follow. It will happen. If you ask me when, then I will tell you some date, but you have to start that portion, right? Yeah. Yes, the correct answer is scalar, scalar, vector. Yes. Mass of an object, scalar quantity. Mass of an object, scalar quantity. Number of leaves, no direction needed. Scalar quantity. Velocity, vector quantity. Scalar, scalar, vector. Correct. Which of the following is always positive? Vector, magnitude, direction, tensor. Magnitude means value. The value of something, the modulus of something, mod of something, the thing, that value which you associate will be always positive. Hence it is magnitude. Yes, magnitude. Magnitude also is the modulus of a vector quantity. Like for example, over here, this 2, this number 3, this 1, these are the magnitudes. Magnitude and direction. Direction is that north, east, west, whatever it is. So 2 Newton, 3 Newton, 1 Newton, that 1, 2, 3. All these are values, magnitudes. They are always going to be positive. Very good. Modulus also means this. Minus 5's modulus is 5. 5's modulus is also 5. So this is basically your magnitude. Magnitude, modulus, mod symbol. Okay, moving on to the next question. Which of the following is a vector quantity? Which of the following is a vector quantity? Distance, speed, acceleration, more than one of the above. Distance, come on, I just told you speed, acceleration. I think distance and speed, both. I don't care about the direction. Speed, I don't need the direction. Yes, so only acceleration I do need the direction. This is a scalar, this is a scalar, this is a vector quantity. So only one of them is a vector quantity. Yes, C for your Capto or C for Captain Shreyas. Correct. Which of the following is a vector quantity? Momentum, mass, weight, force. Momentum, mass, weight, or force. Come on, think about it carefully and answer in the chat box. Think about it carefully and answer in the chat box. Momentum, mass, weight, as well as force. See, think logically, my dear students. Think logically. Momentum, I need the direction. Momentum is 100 in this direction. It is a vector quantity. Mass, I don't need the direction. Just tell me how much mass it is. It is scalar. Weight is the force of gravity. Weight is mg. It is force. Force acts downwards. Downwards is the direction. It is a vector quantity. Force is also a vector quantity. So which of the following is a vector quantity? Think about it. A, C, and D. A, C, and D. A and C, yes, even D is there. But out of these options, only this option makes sense. Only this option makes sense. Yes, A, C, and D. So D option is the most appropriate option, even though D is not marked. Because only D is wrong, only C is wrong, both A and B is not correct. So those three obviously go wrong, hence option number D. Is that clear, everyone? Okay, perfecto. Now, how do you represent vector? See, this is very, very important. How do you basically represent vectors? Say, for example, Pandu is one person, moves 2 kilometers, 2 kilometers towards northwest. This is in words. And what am I asking over here is displacement of Pandu. Displacement. Displacement is how much? And you reply to me, Pandu's displacement. Pandu moves 2 kilometers towards northwest. Is this a vector quantity? Yes. I hope you can see this 2 kilometers. This is nothing but the magnitude towards northwest. This is basically the direction. Hence, this definitely is a vector quantity. This is one way to represent it in words. Beautiful, nice passage you can write. But don't you think it is very lengthy? Don't you think it is very lengthy? Yeah. So, Pradeep, JEE and KCET syllabus, some chapters in KCET are not there. Number one, some chapters might be there. We have to wait for the brochure to come. But more or less, 99% it is same. Number two, the weightage of the syllabus is different. In 12th, the syllabus weightage is more for KCET. But for JEE, 50-50 weightage is there, both for 11th and 12th. That's the main difference. Okay. Apart from that, yes, I have made a special video about KCET also, just like Abhishek told. Okay. But is there some better way? Answer is yes. You can show it via diagram also. How? I can say, okay, this is where Pandu was. He went like this. And then I can put one legend over here like this. And I can say this is north. This is, sorry. I can put one legend over here like this. This is north, this is south, this is east, this is west. And I can also say this scale over here, you would have seen map view. This scale over here, this is, probably one scale which is given over here. This is, let's say, 1 kilometer. This is, let's say, 1 kilometer. If it is given like that, northwest. So northwest will be somewhere like this. Is that right? Northwest will be somewhere like this. This is 1 kilometer, 2 kilometers. So this is basically the way in which you represent it. So he started from here, and he reached over here. So this is your displacement. This is how you represent it diagrammatically. This starting point is often called as the tail where you start. When you reach, that is also called as the head of the vector, and the length of this is the magnitude. The length of this is the magnitude. And wherever the arrow points is pointing in the direction. Wherever the arrow points, that is the direction of that vector. So direction is taken care, magnitude is also taken care. Is this absolutely clear? This is the diagrammatic way of representing it. But you can also label this like this. You can say displacement, the symbol is S, and you can put a bar over here to label this. Or you can also put S with an arrow mark over here. Both of them are okay. Whenever there is a bar or an arrow mark, it means you have to give me the direction. You can't escape without giving the direction. That is why I have given magnitude and direction both. So you put a bar or an arrow mark. Don't think, sir, this arrow mark tells me the direction. Wrong. A lot of people think, sir, I am going northwest. So should I put it like this, sir? Northwest, no? Like this. No, wrong. That is not correct. Just put an arrow mark. That arrow mark just tells direction should be given. It does not tell me what the direction is. So to tell the direction, you have to put it in words or put it in diagram. Is this clear, everyone? Okay. Sir, but isn't this a much longer way of writing the vectors? I completely agree. So let me show you very important things over here. When I write S and I put bar, it means I have to give magnitude also, like for example 2 kilometers, let's say northwest. It will be wrong if I just put 2 kilometers or if I just put northwest. That is also wrong. So this is not correct. This is not correct way of writing it. This is the correct way of writing it, because both magnitude and direction are needed. But look at this now. If I just put S or S bar modulus, I am not putting a bar nor I am putting an arrow mark, then I am just interested in the value. So just put 2 kilometers or just put 2 kilometers. I am not interested in the direction. So this is correct. This is called as the magnitude of a vector. This is called as the magnitude of that vector quantity, which is basically just the value of it. It is just the value, modulus. So whenever I put mod, it means the length of that. How long is this? 2 kilometers, 5 Newton, 7 meters per second, 3 meters per second square. That value is the magnitude. If I put bar, I have to give magnitude and direction both. Is this understood? Do you guys agree that without learning this, there is no point learning electrostatics or electromagnetism or ray optics or anything? Do you guys agree or not? Should we not complete the basics first? Yes? Very good. Yes, it is always going to be positive. But then, I don't like representing vectors like this. It is a tedious task for me. Think about it. Yochna madi. Every time writing big statement, I have traveled 2 kilometers towards northwest direction. This person is moving at 5 meters per second in the south direction, slightly making 20 degrees with the west. Tumma jasti information, too much. I want a simpler way of representing vectors. I want simpler way of representing vectors. So let me tell you a simpler way, but before that, remember one thing. If I put a vector A and then I put another vector like this over here, B, such that the length or the magnitude of B is the magnitude of A and direction of B and A are same, they are pointing in the same direction, then A bar and B bar are equal vectors. What are they? They are said to be equal vectors. Keep this in mind. They are said to be equal vectors because they are of the same length and same direction. It's not like one is like this, one is like this. No, same direction. Similarly, if I put another vector like this, C vector, such that the magnitude of the C vector is the same as that original A vector, but the direction of C is opposite exactly of the vector A. Wherever A is going, exactly opposite to that, but length is same, then C is a negative vector of A. Then C is a negative vector of A. So it is represented like this. C bar is negative of A bar. Here while writing, I will write, because A and B are equal, B bar and A bar are equal. I will not put minus sign. This is something which you should know. This is something which you should know. Swalpa thickness kami ಮಾಡಿ ಸರ್ ಮಾರ್ಗರ್ದು ಅಕ್ಷರ ಬಾಲ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ. Okay, fine. I will slightly reduce this. Okay, ಅಕ್ಷರ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ. Okay, fine. Okay, sorry. Pink color, good. All right, fine. All right. So this is something which you should know. Now observe this very important thing. If by chance if by chance there is a donkey, look at this, this is a donkey. What does donkey do? Donkey yen ಮಾಡ್ತೀನಿ whole day? Staying there, doing nothing, no force, no velocity, no displacement. If somebody asks me displacement of that donkey, what will you say? Displacement of the donkey? 0. Velocity of the donkey? 0. Force on the donkey? 0. So these are called as null vectors. Null andre 0, null, nothing, waste fellow. Yes. Sleeping donkey, nothing, doing 0. So null vector agutte. Okay, that is null vector. Idu equal vector, idu negative vector. Negative vector. Pandu going this way, opposite of Pandu, same magnitude, that is negative Pandu. This is equal, this is negative, this is nothing. Now comes unit vector. Let's understand this. Example. Imagine somebody goes this much and this is exactly 1 unit. This is called as a unit vector. Let us say in that same direction, there was some another vector, let's say a vector. So a vector in this direction but of unit length will be just written down like this: a hat, cap, topi, cap, yes, hat, whatever you want to call, is an unit vector in A's direction. Similarly, imagine there is some vector over here, p vector. What will be p hat? In that same direction, unit length. This will be p hat. This length will be 1 unit, whatever it is, 1 Newton, 1 meter per second, 1 meter per second square, 1 Weber, whatever it is 1 unit. Is this absolutely clear? P hat. Who is Pandu? Pandu is some example, some random person. Pandu, Champa are imaginary people in our classroom. No random, some random thing. Okay. Is this clear? Unit vector, what is the meaning? Okay. Now there are 3 different axes for us. X-axis, Y-axis, Z-axis, 3 dimension. So, idu X-axis, idu Y-axis, idu Z-axis. A vector in the X direction of unit length. Has a special place in physics. It is called I cap. In the X-axis direction, unit length 1 kilometer, 1 meter, 1 centimeter, 1 Newton, 1 meters per second, 1 something, 1 unit is I cap in X direction. After I, which alphabet comes? A, B, C, D, E, F, G, H, I, J, K. So J comes after X. So after I, sorry. So this is called J cap. After J comes K cap. So unit in X, I cap, unit in Y, J cap, unit in Z, K cap. These are the special unit vectors. Hat does not mean direction. It says it has a direction but with unit magnitude. It is a vector with unit magnitude. So tell me, what is the answer for this? A hat modulus. The answer for this? Yes, it will be 1. Always whenever there is a hat, modulus will be 100% 1. But remember this, but A bar modulus may not be 1. Because it might be more than 1, less than 1, equal to 1, we do not know. It may or may not be 1. Ooh, is it Krishna? My God, where and all should I be? I will make that announcement. Oh, see, during my lecture only, idu announcement banute. All right. So JEE mains, is it? Nothing as of now, unless oh, it has come. Yes, it has come. Yes, inviting the online application forms for JEE. Do application form notice bandidare. Look at this, online application form 28th October, last date 22nd November. Yes, Kannada do. You can give the JEE main exam or English also. Yes, dates bandidaru. Look at this. Where is it? Where is it? CBT. Really their dates. Dates of exam, 22nd to 31st January. 22nd to 31st January. I had predicted this. Idu nanu predict madidare on JEE English channel. It will be after 20th only. And in fact, I think I had told 21, 22 only it will be there. And same dates it has come. Anyways, so this is your JEE notification. You can see section A, section B, everything has been mentioned. Have they mentioned about paper 1? Each subject will have 2 sections, multiple choice. There will be negative marking in both the section. Ayo, this is full tension. Section A, section B, both have negative marking. Ayo. Okay. Anyways, all these things are mentioned. Anyways, I'll make a separate video on the JEE English channel after this. JEE English channel, it's here. Okay. Same, most of the teachers are very, very similar. So we'll be making a separate session on that. All right, cool. Yeah. Yes. Thank you, Krishna, so much. Always need students like you. Thank you, Pandu. Okay, so that was unit vector. All right. Now you'll be like, sir, why did you discuss about unit vector? See, our main problem was, idu tumba kashta aitu to represent these vectors with so much magnitude, direction, big statements. So is there an easy way? The answer is yes. Imagine I tell you something like this. Pandu moves 2 kilometers along the x-axis and 3 kilometers along the y-axis. That is the displacement of Pandu. Can I write this as, think about it, he moves 2 kilometers in x. In the x direction, 2 kilometers. Each kilometer is I cap, 1 unit. 1 kilometer is 1 unit. So can I say Pandu has moved 2 kilometers in x direction. X direction means I cap. He moved 3 kilometers. That means 3 units. But in y direction, adandre j cap. And he did and, means both of them together. He once went this and this together. So you add them, hence you put a plus symbol. Isn't this a much better way of writing this? 2i cap plus 3j cap. 2i cap plus 3j cap. Sir, class 12 matte kinematics madire KCET marks bandidu sir. Class 12 Mallikarjun almost 70 to 80%. But yen problem ande, see, the class 12 syllabus you can't study separately. That is a major mistake which students are doing. That is what most students don't understand. You join some batch thinking, oh, I will only study 70-80% syllabus, which is class 12. But so many things are dependent of 11th standard. If you don't know kinematics and vectors, you can't understand how to, how to solve this electrostatics magnetism problem. What is this cross product, dot product? What is this energy? What is this work? What is this momentum, angular momentum? So many things. Mole concept, IUPAC nomenclature, wavy method, inequalities, quadratic equations, trigonometry, basic maths, integration, derivatives. All these things are amele only you can start studying 12th standard, understand that. Yeah? Clear? Okay. You know now how diagrammatically it is so simple. See this, observe this. This is x-axis, this is y-axis. This is x-axis, this is y-axis. Tell me 2i cap. 2i cap means I cap, I cap, I cap, I cap. So what does this become? Yes, it becomes 2 times of I cap. Correct? 3j cap. Amele. 2i cap amele 3j cap. J cap as in y direction. So 3 times j cap, j cap, j cap, j cap, j cap, j cap. What is this? What is this? This is basically 3j cap. Idu amele idu. So basically my displacement is from here to here. This is my vector. This is my displacement. Artha ayutta everyone? Yes. Is this absolutely clear how this works? How this works, everyone? Absolutely clear? Yes. Yes, Sudarshan, 12th standard will also start simultaneously. I am doing basics first, or else you will only be like, sir, please teach that. Okay. Now, if I ask you this, S bar modulus, what will you say? You will look at this triangle and you will realize immediately, sir, idu 90 degrees, sir. Idu right angle triangle, sir. Sir, idu hypotenuse, sir. Sir, idu base, idu height, sir. Sir, hypotenuse square is by Pythagoras theorem, this side square plus this side square. Yes or no? So, sir, this is equal to 2 square plus 2 square whole thing, sorry, 2 square plus 3 square under the root. 2 square 4, 3 square 9, 9 plus 4 13. So root 13. The length yes to root 13. Done. Magnitude. That andre magnitude. S bar modulus. Understood? Absolutely clear. Good evening, MM. Everybody understanding till this point? Clear? So now tell me one thing. If somebody tells you like this, hey, S bar is 4i cap minus 3j cap. Don't get tensed. Sir, 4i cap minus, sir. Don't worry. 4i cap andre I cap, I cap, I cap, I cap. Idu 4i cap, correct? 3j cap but negative j cap. Negative j cap andre idu positive, idu negative. Up positive, down negative. So 3 negative 1, 2, 3. Idu minus 3j cap. So ಆಮೇಲೆ ನನ್ನ ಹತ್ರ vector idu. This is our vector, this and this. So this is my displacement. So I've gone like this. I've gone like this. Done and dusted. So simple, right? Yes, correct. So if somebody asks, what is the magnitude? What will you say? Root 4 square plus minus 3 square. 4 square 16. Negatives square is positive only. 16 plus 9, 25. So it is just 5 units. So it is just 5 units. Clear? Yes, correct. Now similarly, sir, what if some vector is there and it says 2i cap minus j cap plus 3k cap, sir? What to do? 3 things are there. Or let's say I put plus j cap for now to understand, make you understand simply. 2i cap plus j cap plus 3k cap, meaning 3 dimension. Okay. First you go in the x direction. How many times? 2 times. I cap, amele I cap, 2i cap. J cap, only 1 time. Y axis. 3k cap, out of the plane. See, my board is 2 dimension. There is no 3D. Your screen is also 2D. I can't show 3D. So I'll try to make you visualize 3D like this. 3k cap means 1 time, then 2 times. Oops. This is 1 time, then 2 times, and then 3 times. This is in 3 dimension. Swalpa yochna madi. It is something like this. This is our vector. This is our x-axis. This is our y-axis. Idu z-axis. 3D mele yochna madi. Imagine some cube or cuboid, you will be able to visualize this. I have gone east, then I have gone up, then I have come like this, then like this, then like this. So this is the vector in 3 dimension. Okay, so it's slightly weird to visualize, but it is there. It is somewhere here. This vector is somewhere over here. This is my vector in 3 dimension. This is that vector in 3 dimension. Visualize that slightly. Yeah. I hope everybody had 3D screen. What is the definition of a unit vector? A vector whose magnitude is unity is called unit vector. Length is 1 unit. Direction could be anything, doesn't matter, but length should be 1 unit. Direction can be anything. Is that okay, Rajesh? All right. Now, if somebody asks you what is the magnitude of this, like, sir, you didn't teach that, don't worry. I've taught you this, no? If there is one more thing, what will you do? Do the same thing again. That's all. So you will just do 2 square. What is the unit? 1 square and then 3 square. The coefficient, indirectly there is 1 over here. So 1 square plus 3 square. 2 square is 4, 1 square is 1, 3 square is 9, 9 plus 1 is 10, 10 plus 4 is 14. So magnitude of it, length of this is root 14. Root 14. Understood? Clear? So can I now say, for me to represent any vector, I will show you a beautiful diagram. So after this, you will never ever cry about it. Observe this. Slightly difficult for me, but still I will try. See if you are able to visualize this cuboid. Basically a room, x, y, z axis. See if you are able to visualize this. Everyone, can you visualize this? Okay. Now imagine my vector to be like this. This is my vector. From one side to the other vertex. From one corner to the other corner, like that. It's the diagonal. It is the diagonal from one bottom to the other on the top vertex opposite side. So can you see this one over here? Let's say like this. Like this it is basically. I have to just redraw so that you get a sense of the depth. Then I basically go, let's say, like this, and then I basically go like this. Each one of them is along different direction. This is my vector. This is something in the horizontal direction times I cap, like that, some number of times. How many number of times? Vx number of times. Like this one. This 2 is that Vx. This 2 is basically that Vx. This 1 is basically that Vy. This 3 is basically that Vz. Getting it? So similarly, in the y direction, I have gone some number of times. In the z direction, I have gone some number of times. How many number of times in the y direction? Vy times. How many number of times in the z direction? Vz times. Vz times. Are you now able to visualize this cuboid? Yes. Super, sir. Very good. So, any vector will always be some Vx, Vy, Vz with some additions, of course. Oops. like this: Vx I cap, Vy j cap, Vz k cap. And if somebody asks you what is the magnitude of this, it will be always Vx square plus Vy square plus Vz square. Always. You should know this. Next important thing, what is this Vx, Vy, Vz also called? These three, Vx, Vy and Vz, are the components of the vector V along x, y and z axis. Along x, y and z axis. Is this absolutely clear? These are just the components of the vectors along each of the direction. Correct. Very good. So now you know how unit vector is useful to represent anything. So tomorrow, and this is the magnitude. Say for example, you get a question, calculate the magnitude of 4i cap minus 3j cap plus 7k cap. What will you do? Come on, calculate the magnitude of this vector. Magnitude of a vector means a bar modulus. What will you do? Take the components, each one of them, square them, add it inside the root. First is 4. This is your x component. Next is minus 3. Next is 7. And now add them. So 4 square 16, 3 square 9, 7 square 49. What is the answer going to be? Come on, my dear warriors. Quickly tell me the answer. 64. So 8. Pakka? Yo. What are you saying? No, it is not 64. 74. Yes, 74. 74 is root. Correct. That is the answer. Root 74 is the answer. Yes. Yes, JA aspirant. I just saw that, and I think just some time back I showed that JA notice also. I'll come on the JA channel also in a bit. Next, the magnitude of the given vector with the endpoint. Sometimes you get like this. These kind of questions. So there is one point mentioned, another point mentioned, and then they ask you, what is the magnitude of this vector? Don't get scared. See, what they have given you is with the endpoints this and this. So one of the points over here is 4, minus 4, 0. Other point is minus 2, comma 0. Whenever you get such questions, what you do, first see what our actual vector must be. Our actual vector is, do one thing, this is x coordinate, this is y coordinate, this is z coordinate. Take the difference of the x coordinates. 4 minus minus 2. 4 minus minus 2. That is I cap. Minus 4 minus minus 2. Plus minus 4 minus minus 2. That is j cap. Plus this minus this. 0 minus 0 k cap. Just take the difference of the coordinates and put I cap, j cap and k cap. Make sure you maintain the order. First, if you do 4 minus minus 2, next time don't do this minus this. This minus this, this minus this, this minus this. Always. Is that clear, everyone? Everybody with me? Everybody with me? Alright. But the right way, sir, you will be like, sir, should I do this minus this or this minus this? The answer is always final minus initial. So this is not correct actually, because always you should see this is the final point, this is the initial point, final minus initial, that is the right way. So minus 2 minus 4, that is I cap, plus minus 2 minus minus 4 j cap, and 0 minus 0, 0 minus 0 k cap. So this will be minus 6 I cap, this will be plus 4 minus 2, which is plus 2 j cap, and 0 k cap. So the magnitude will be minus 6 square plus 2 square plus 0 square, nothing is there over here. So 6 square 36, 2 square 4, So root of 40, which is root of 4 into 10, root 4 is 2, so 2 root 10. So 2 root 10 का answer बने दो, 2 root 10. Got it, everyone? Understood? Clearo? Shall we go ahead? Shall we go ahead? Yeah, that is the magnitude of that vector. Now, very interesting question. 1 by root 2 I cap plus 1 by root 2 j cap. I hope you can see it. It is not very clear. 1 by root 2 I cap plus 1 by root 2 j cap is a unit null vector of magnitude scalar. 100% it can't be a scalar because I cap and j cap is there. So remove this option. Okay. Is it null vector? 100% not null vector. Why? Because something is there, no? Something in I, something in j. So it can't be null vector also. Either it is this or it is this. If it was a null vector, it will be 0 I cap, 0 j cap. 0, 0. Everything will be 0. Nothing will be non-zero. So both these options only remaining. So let's do one thing. Let's find the magnitude of this vector. When I try to find the magnitude of this vector, I will do 1 by root 2 whole square plus 1 by root 2 whole square. X component square, y component square. 1 by root 2 square is 1 by 2. This also 1 by 2. 1 by 2 plus 1 by 2 is 1. Root of 1 is 1. Sir, the magnitude is 1, sir. What is it? Unit vector. Hence the answer is unit vector. Got it? How to solve the question? Everybody clear about this? Everybody clear? Understood how to solve the question? Very nice. Okay. Can you solve a very similar question? The question is slightly reverse. One of them is a unit vector. One of them is a unit vector. Can you quickly identify who is that? Okay. Try to find the magnitude for every one of them. This guy's magnitude, I cap plus j cap. It will be 1 square plus 1 square, which is root 2, which is 100% not 1. This is already only in one direction, I by root 2's magnitude. Only one thing is there. So it is just 1 by root 2. This is also not 1. If you see the third option, the magnitude of k cap minus I cap by root 2, the value with k is 1, the value with I is minus 1 by root 2, which is 1 plus 1 by 2, which is 3 by 2, which is again not 1. So that is also not unit vector, but this I think it is. The magnitude of I cap by root 2 plus j cap by root 2 is, the x component is 1 by root 2. So 1 by root 2 square. The y component is also 1 by root 2. So 1 by root 2 square. 1 by root 2 square is 1 by 2. 1 by root 2 square is 1 by 2. 1 by 2 plus 1 by 2, 1. Root of 1, 1. Yes, this is unit vector. This is, oh, this is wrong answer marked. This is the unit vector. Is this clear? Yes, D answer, correct. Very good, very good, very good. Yes. Now, sometimes the questions are slightly modified and they will ask you, what is the unit vector in this direction? So, what to do in such cases? Let me tell you. When they ask you unit vector in somebody else's direction, if you remember correctly, if this was, let's say, a vector A, a unit vector in that direction, a unit vector in that direction was like this, correct? This is having exactly 1 unit. Tell me, if I take this 1 unit, 1 unit, 1 unit, 1 unit, how many such A hats will fit in over here? How many such A hats will fit in over here? The number of A hats that will fit in over here will be the magnitude of this vector. maybe the length of this vector is 7 units. If it is 7 units, 1, 1, 1, 1, 1, how many times? 7 times. So that is basically the magnitude of that vector, meaning modulus A. Is that right? Modulus A times. Is that right? Yes, correct. So can I then say A hat, how many times? Modulus of A times will give me this vector, that means A vector by modulus A, what does it give me? It gives me A hat. So this is very important formula. A hat is A bar by A modulus. A hat is A bar by A modulus. A hat, 7 times. 7 is the magnitude. A hat times will give me the total vector. So if I take this below, A bar by A modulus will give me the unity vector. That's how I do it. So let's see a question based on that. How questions are asked. Observe this. Unit vector in this, for this vector is how much? They are asking you basically R hat is question mark. R bar is given, R hat is asked. So R hat is what? R vector by modulus R. What is R vector? 3i cap, 2j cap, 2k cap with negative sign. Whole thing divided by modulus. Modulus means magnitude. Magnitude of this, what you do? Root 3 square, 2 square, minus 2 square. What will this be? Let's see. So 3i is there, 2j is there, minus 2k is there. Whole thing divided by 3 square, come on, how much is it? 9. 2 square, 4. Minus 2 square, 4. 4 plus 4 plus 9. Come on. 4 plus 4, 8. 8 plus 9, 17. So root 17 should be there below. Root 17 should be there below. Is there root 17 somewhere in the options? Yes. This is the option. This is the correct option. Is this clear in everybody's head? Option A. Very good. Very good. Very good. So we have done till here. We will do the next part in a separate lecture. Have you understood all of the vectors part, the basics of vectors? There is more to it. We'll divide this into 2-3 parts if needed, like I said before. I want everyone to practice problems on magnitude of a vector, representing a vector, difference between scalars and vectors, okay, and unit vector notation. Adding, subtracting, we'll do it in separate class. Adding, subtracting and kinematics, we'll do it in a separate class. Till this, if it is clear, then I'm happy. Cool? All right. We will meet. Did you enjoy the class? Did you enjoy the class? Like Madi and join the channel, subscribe free of cost. Okay? Do that. I'll see you in the next class, and next class is at 9 o'clock. Okay? I think it is Namrata ma'am or Gopika ma'am, one of them. Okay. Thank you so much. Bye bye. Hasta la vista. Take care, bros. Have a great time. Have a great time.